It can be used to design all kinds of networks, including communication, computers, transportation, as well as electrical, by providing the cheapest way to achieve connectivity. So Prim's algorithm, as it will allow you to find the cheapest possible way, and also it takes care that there will be a path between every pair of points. So it can be used in applications like networks, wherein it can be used for communication, computer, transportation, and electrical, by providing the cheapest way to achieve connectivity. And it has been used for classification purpose in archaeology, biology, sociology, and other sciences as well, and also to construct approximate solution to more difficult problems such as traveling salesman problem. You will come across this traveling salesman problem in the further modules as well as in this. So here your Prim's algorithm will find the application. Okay. So if everyone is okay with Prim's, we'll move on to Kruskals algorithm. Both are used to find the minimum spanning tree. Okay, no doubts with Prim's. Everyone now okay with Prim's algorithm? In that case, we'll move on to Kruskals. Let me use a whiteboard and explain it for you. And have posted I've posted assignment 2. If you have gone through in MS Teams, questions I've given from module 2, and you will have to write the assignment and submit by Monday. And at 3:45 today, you will have one quiz. Okay, I've scheduled a quiz at 3:45, so that at 3:45 you'll be able to view the questions, answer for those questions, and submit the answer. Okay. So before that, let's finish with this Kruskals algorithm. Yes. So this is another greedy algorithm for finding the minimum spanning tree, and this always yields an optimal solution. This Kruskals algorithm always yields an optimal solution. You know the difference between optimal solution and feasible solution, isn't it? Feasible solution, you can have many. Optimal solution will be the one which will try to either maximize or minimize. So your Kruskals algorithm. So what is the topic we are discussing? Let me write down that first. Kruskals algorithm. And what are the methods we are checking here? What is the method we are following? Greedy method. So it's another greedy algorithm to find the minimum spanning tree, and this always yields optimal solution. Fine. Always yields an optimal solution. Here, the algorithm will just try to find a minimum spanning tree for the given graph. As you know, here also we should have an acyclic subgraph with the number of vertices minus 1 edges, and when we add those edges, the sum of those edge weights should be smallest. There also smallest, here also smallest, and we will have construct a minimum spanning tree by expanding, as in your Prim's as well. We will just expand the sequence of subgraphs, and we should always check whether it is acyclic, and then we move on to the intermediate stage of the algorithm, and like that we will complete it. So the procedure what we follow in Kruskals algorithm, both Prim's and Kruskals are used to find the minimum spanning tree, but the procedure which is followed are different. The procedure what we follow for this Kruskals algorithm, say have you all checked your MS Teams, all module notes, PPTs I have uploaded, and I've also uploaded the notes for 3 modules. Okay, you can just check. So you can complete your assignment. If you have any doubt, you can always ask. And don't forget to write the quiz at 3:45 p.m. today. I'll leave it 3:45. You can finish your quiz. And so the procedure, whatever we follow in this Kruskals algorithm will be, we first sort the graph edges in non-decreasing order of their weights. What do you mean by non-decreasing order? These are the terms whatever we will use, non-increasing order, non-decreasing order, like that. There's nothing but ascending order. Don't get confused like with that. So non-decreasing order of their weights, that is according to the increasing order of their weight of the edges, we will just sort them. And then we'll first start with an empty graph, subgraph, and then this sorted list will be scanned, and next edge will be added to the current subgraph. If at all, if inclusion of such an edge will create a cycle, we'll just skip that and we'll move on to the next edge. Likewise, it's very simple when compared to your Prim's algorithm. So for the same graph, whatever we did, 1 second. So we have for the same graph. So what's the procedure? The procedure is we start first, we will sort the graphs. Is everybody following? Able to hear me? See the screen?
Yes, ma'am. Yes, ma'am.
Yes, don't sleep. Huh? It's afternoon. Non-decreasing order of their weights. Okay, then this is the first step, and second step we start with empty subgraph. Then we scan the sorted list. Okay, because we have the list sorted here, we will scan this sorted list and we'll check whether adding the next edge to the current graph, whatever graph we have, to that, if we will try to add a new edge, is it creating a cycle? If it is creating a cycle, just skip this edge. Don't include this edge. Skip that edge. And just select the next one. Okay. We'll check whether it can be included. Including that, if it creates a cycle, don't include that edge. Move on to the next one. Okay. We'll start with the problem. Shall I rub this off? Yes. So this is a problem. For our reference, we'll just write down it as Kruskals. Both algorithms are used to find the minimum spanning tree, but this algorithm will always give you an optimal solution. So we have a graph, same graph we take. A, B, and one more example you will solve. Every time it will be the same case. I'll solve one and you will solve one more. Okay, this is our graph. Let's follow the procedure. The tree edges, whatever we will select, we'll write down here, and we will write the sorted list of edges. Now you will tell me in ascending order I should sort the edges and list down. Which is the first edge? It should be in order, non-decreasing order, which means increasing order. Which is the first edge which will come in the list?
A.
Here, this edge with the smallest weight, B to C. So we'll write down like this, BC, and the cost is 1. Next, which is the next edge? F, EF, we'll take in order, EF. EF, what's the cost? 2. Which is the next edge? Now you got an idea. You tell me now. Next edge in the
AB.
list? Yes, AB. Then, what's the next weight? BF and CF we have. We'll take in order. First BF and then CF with 4. Next, we have AF with weight 5. Then we have DF with, we are taking, going arbitrarily, FD, and why we have not written FD, you should not get confused. We should go in order, arbitrarily. Okay, 5. Then, what's the next edge? A to E, which is 6. And C to D, which is 6. And the last one is D to E, which is 8. So we have sorted all the edges in the graph. Is that clear till here?
Yes, ma'am.
Yes, for everybody.
Yes, ma'am.
Yes, this is not that tough when compared to your prims, isn't it? So among this, we select the least one. So only we ask you to arrange it in order, non-decreasing order of the edges, weight of the edges. Now, smallest we'll select, we'll add it here, BC with 1. Next, which is the other one we can select, we have to write it down all the time. Steps will carry marks. AF, DF, AE, CD, and DE, which is 8. Now, when BC is selected, which is the next smallest? Which is the next smallest we have? We have this EF. We will highlight that. We will highlight and say that this is selected. Next, E and F. You have to show it in the graph as well. So we'll, second step. Ma'am, it's so boring to write the graph again and again. If you will fail, you will lose marks. How long it takes to write a rough sketch? First, which is selected is this one with weight 1. Now we have selected EF with weight 2. Others 3, 5, 6, 4, 4, 5, 6, and 8. Okay. So 2 edges we have selected. Next one, after selecting, so we have selected EF and 2. Now, which is the next one we have to select? We also should check whether it is creating a cycle. No, this is not creating a cycle. Hence, we have included both. Now, let's check with selecting the next one. Hard work always gives you fruitful results. Don't become lazy. Okay, now this is the next one, A to B. Can we select A to B? Yes, it's not creating a cycle. Is it creating a cycle if we select A to B? Answer for this? check whether it is creating a cycle. If it is not, then you select it. Otherwise, you have to move on to the next one. You have to skip that. Next highest will be A to B. Is it creating a cycle? Look into the graph and tell me. Yes. I'm trying to select AB.
No, ma'am.
Yes, it's not creating a cycle. So I will just highlight this. And I will highlight here as well to show that this is what we have selected. Okay. Yes. So what is the next edge we have selected? AB 3. Now BC, EF, AB 3. Then we have BF, CF, AF, DF, which is 5, AE 6, CD 6, and DE 8. Next edge B to F. See here, which is the next one, B to F. Let's select, check here whether it is creating a cycle. Is it creating a cycle? No. So we can select this next. Okay, I'm highlighting that here as well. I'll say that I'm selecting BF for the next one as it is not creating a cycle. And that is the next in the list. In the sorted list, that's the next one. So done. Now, so we have selected BF with a weight of 4. Next, yes. So BC, EF, AB, BF, CF, CD 6, D 8. Next, what's the next? What we have? Tell me now, answer for this. Can I select CF here? Can I select CF here? That's the next one in the list.
Ma'am.
Can I select? What's the
No, ma'am.
Yes. What is the procedure you should follow? The procedure says that once you try to select an edge, you always check whether it is creating a cycle. See here, if I select CF, this will become a cycle. Clear? All are listening?
Yes, ma'am.
Only Rachita will
Yes,
answer all
ma'am.
the time. Okay, who is that? Only two, three girls will answer. What about boys?
Yes, ma'am.
Okay. So C to F, if we will select, it creates a cycle. So what does the procedure says? If it's creating a cycle, you will have to skip that and move on to the next one. Let me check with AF. See, AF. Is it okay to select AF now?
No, ma'am.
Because it
No,
is
ma'am.
creating a cycle. Yes. So we will skip that also. Now DF. We'll try with DF now. D to F. Is it creating a cycle? Is it
No,
creating
ma'am.
a cycle? No. So I can select DF now. So what's the edge which is selected? It is DF and the value is 5. So we selected DF with value 5. And have we touched with all the vertices? You check. A, B, C, D, E, F. Okay, all the vertices we have just covered, and also it is acyclic, and we have just ended the problem. So now what's the cost? 3 plus 1, 4, 8, 10 plus 5, 15. What's the cost? 4 plus